Okay. Uh, Good morning, everyone. Thank you very much. Well, we started this morning actually with heavy mathematics, and then we jumped to uh, education, and then to design thinking or thinking and fuzzy logic. And now I will move you to something more different, something more practical, more easier. And I promise to make it very easy, very simple, that everyone can understand it very easy. My name is Hassan. I am from the High College of Technology in UAE. The High College of Technology is a very big university that has many campuses, more than 27 campuses all over the country of UAE. I'm working for Sharjah, which is very close to Dubai. Today I will talk about design of the solar photovoltaic tracking system for sustainability approach. Um, in this presentation, I will highlight the introduction, then I'll move to the problem and what is the objective or the motivation. Then I'll move to the background, talking about the system that we are talking or the model. After that, I will highlight the design and conditions, the method that we use, then the result, data analysis and discussion, and I conclude my work, and I will end with the future work for our presentation. So we know that our civilized society encounter many hazards. These hazards actually related to food, water, and many resources and environmental, especially when we are talking about new technologies and the new inventions. All of these hazards actually related to energy. With increasing or growing demand for energy, there is a decrease or depletion of the natural resources, which mean we need more and more different kind of energy sources with regard to the future energy supply, environmental impact, and energy conservations. This lead many of us or society as researcher to, as scientists actually, to think about renewable energy. And when we are talking about renewable energy, which is the alternative simple solution for our problem or crisis that we will have, we always think about solar energy. Solar energy, not only the solar energy for generating electricity and thermal, or mainly in this work, we will concentrate in solar panel, which is the photovoltaic solar panel, the most perfect source of energy or renewable energy, especially when we are talking about countries, sunny countries like UAE. Simply, solar energy, it is environmentally friendly, CO2 free, better world, and it will lead for zero electrical bill. But there are some challenges or difficulties usually that we face when we are dealing with the solar panel. Still, even we have high technology, still the power output are not that huge, and the efficiency of the solar panel is still very low. And the solar panel, it need a huge area of installation. The solar panel is highly scattered, are not in one place. We need to focus it in some focus or focal area in order to harness it and to get it more efficient. Which means we need some techniques or some method for tracking the solar from the sun in order to concentrate it and give it to the solar panel. What is the objective? Increase the efficiency and the power output. Then the PV need tracking system to increase the efficiency, to increase the power output, to generate meaningful amount of energy. If we look for this small figure here inside, and we will find that the solar panel, usually we install it And you know that the motion of the sun is different from winter to summer. So the solar panel should be rearranged, or the inclination of the solar panel should be modified actually twice to four times every year, depending on the season, in order to get more energy from the sun, which means we have to move the solar panel, the normal solar panel, many times during the year in order to get more energy. This is not only the reason, this is not only the whole problem. There is another problem. The sun also get set, started from the east to the west, and then, which means the solar panel should move from the east to west in order to get more energy. But this not happen for the fixed solar panel, which is one of the challenges that we are facing for the solar panel. So what is our objective? The general objective is to replace the use of fossil fuel, build up a better life scale, increase the use of renewable energy, help our society, and focusing more, develop the solar system, talking again about efficiency and power output. Then we need for solar a kind of tracking system to track the energy from the sun. So if we focus more on our objective in this paper, we want to increase the electricity production by following the axis of the sun from the morning till evening, from east to west. And this will help us to track the energy from the solar energy and take it directly to the solar panel. Then we are supporting the solar panel by adding some methodology to track the sun every day. Not every day, or during the year also. So that in this way, the solar panel will face the sun all the time, all the year. So again, what is the objective at the end? We want to save money. How to save money? We will save money by increasing the power output, increasing the efficiency, and not only this, there is one more effective result for this system, that it will save also the installation area. The installation area will be decreasing by using the tracking system. So let me explain about tracking system in general. The tracking system is actually many scientists and researchers in the world, they always thinking about how can we collect the solar energy from the sun by even concentrated, or by how to get it and use it in the normal solar panel. The conventional PV or solar panel are fixed with low efficiency, as I said. Then we need a tracking system to increase the efficiency and the power output of the solar panel. The solar tracking system helps to maintain the solar panel position, and then we will get more energy from the sun. By our calculation of our system, we estimated that the tracking system has about 35% more increase in the power than the normal solar panel, and the tracking system based on a kind of what we call it BLS, or program logic controller, to adjust the orientation of the panel automatically for the solar panel. The principle of the solar panel tracking system, we have actually two kinds of tracking system. One is, we call it single X, that it will move in around one X, right or left, and the other one, which is double X, that will move in the whole direction, up and down, right and left, for the whole direction. These are the principle of working for all solar panel system. Then again, we need to increase the power out for the solar panel, increase the efficiency, and by this one we will save installation area and save money by using this kind of tracking system. The difference between the single and the dual tracking system, that the single one should be adjusted each month and season in order to gain more efficiency. It will increase the efficiency and the power out by about 25%, and it will increase the power output by 15%. While the dual or the 2X tracking system, it doesn't need any adjustment. It will move in all direction, and it will increase the efficiency of the solar panel by about 40% and increase the power production by 35%. And this is why we are moving, or we are we like to use the dual axis solar tracking system, and this is our design here. The principle again, it has some sensors, and it will track the motion of the sun all over the year, because the sun tracked day long with the help of the automated arm running in servo motor to utilize most of the energy from the sun. The design is based on the principle that the sun's ray move according to the angle of instant, which is the angle of the sun over on the earth. Detect using the sensor using the height dependent resistance. It is aimed to benefit from the sun's rays with maximum efficiency throughout the day. We have also two kinds of servo motors that help the axis to move according to the sun angle, and are controlled by the Arduino, which is a small program, or the most famous program nowadays that many people are using to help the movement of the solar panel as per sun position. There are also a number of different mechanisms that we are using in the system in order to get the sign from the sun and return it back to the solar panel in general. So the tracker system is divided into four sections, or four parts, let's say. The first one, which is light sensor, and then light unit, the controller unit, and movement adjustment unit. Each one of these parts has some function in order to get the motion, or to get the order to the solar panel in order to move according to the light of the sun. For example, the light sensor uses the light depending resistance, which is LDR, whose resistance depends on the movement of the light. And the light unit consists of a kind of converter and LDRs. The control unit is a kind of controller or microcontroller that is the heart of the tracking systems or unit, or the controller. The controller is vertical and horizontal. And then we have movement adjustment units. These are the more complicated things if you want to go to more technical issues about the part and how does it work with the logic between them and how it's programmed, how we assemble all of these issues. Here are the component that we use in the model. We started with a small model that is a kind of prototype. We build it out, and then we use it for a bigger model. And of course, we use it for the solar panel, and then we made the cost for the solar panel for a house in order to get the total cost for the house. Here is the prototype that we did it as a real prototype, and the prototype is a kind of small base with many sensors. We have 4 sensors there overall, and all of them are can sense the light, and of course it will move right and left, up down with the motors in order to get the efficiency. Of course, we did the design by designing by the CAD and the SolidWorks for the work, and after the many trial for installation. And here is a small test in the lab that we did using the light of the mobile in order to find out if it is work or not. Of course, here the key point that inside the lab the light is concentrated, then the mechanism is moving directly, and this is only for the presentation to get it more easier. But in the reality, if you put this outside, you will not feel like it is moving because the sun motion is not fast. But if you leave it, for example, after 2 or 3 hours, then you will recognize that it will move very smooth and tracking the sun. Here is the solar panel that we use and the properties of the solar panel and the parameter of the solar panel. Also, we made a calculation for a small house, for example, just to have an idea about what is the result for a small house. Assuming that there are some equipment in the house, and how much power we need for the house. We calculated all the total power for a small house, and then after that we calculated the solar energy that we need for this small house, and we found out that we will need about 16 solar or PV or solar panel for this house, and we will use for those 16 for the with the tracking system in order to see the result. Of course, we need to have the calculation for the inverter and the calculation for the battery if we are talking about the standalone system far away from the grid of the government. And we have here the need of 28 batteries in general for the system. Okay, and here we have the cost analysis. After we having the component for the house with the installation, we said that using this kind of system, we will decrease the installation area, and we made a small calculation for the cost of the electricity, for example, in UAE country, and how much electricity we will save from all total in total. And then we found out that within 8 years or 9 years, we will get our money back, which is some good result for us, which means after 8 years or 9 years, will not pay any single dollar for our system. It will be free forever. As a conclusion, let me summarize everything. We have a small design for a dual access solar tracking system. We designed for one house, and the system will follow the motion of the sun from the morning to evening during all the year, and no need for any adjustment during the year or during the month and during the day, because it has all sensors that are necessary for following the light of the sun all over the year. With good orientation and well calibration of the solar tracking system, we expected that the power output will be increased by about 35%. The increase of the efficiency for the solar panel will be about 52.7, which means this will yield the economy of the solar power planet. I mean, if we are using a solar power plant to generate electricity, it will be a good indicator. The number of needed PV will be decreased because the installation area will be more reduced, or will be reduced more than the normal one. The cost, of course, will be cheaper, and we need about 8.9 years to get the initial cost back, which is a very good and economical period of time. This method can be adopted or any place, over the world, which will increase the efficiency and the power. It is cheap, and it offers a great return on the small investment. What we are thinking for next, generalize and make maybe the actual design. Maybe we will find how can we design a kind of motor or mechanical coil spring load system. It's a kind of without even the motor, or some mechanism that will help the system to reduce the cost and to make it more easier than the normal one. Thank you very much for your attention, and I hope it was useful and easy as I promised. Thank you very much.